Am I supposed to introduce myself now?
Yeah, you guys go ahead, start it.
So I kicked off today for anyone who was here earlier this morning. I co-founded blockchain at Microsoft in 2015, knowing that I would spend at least 10 years in the space, and basically have been down that rabbit hole for 12 years, and then the last 2 years heavily down the AI rabbit hole, as is most of Microsoft. So it's a pretty exciting time, and looking forward to the conversation.
Keep going.
Hey guys, my name's George. I'm Chief Product Officer of Near. For those of you that don't know Near, Near is L1 also building an AI founded by one of the inventors of the transformer. So glad to be here.
Hello there. Okay. Yeah, my name is Sumit. I'm the founder of Chaos Chain. We are building Worldline at Chaos Chain, which is an independent control room for your agentic fleet. So Worldline helps you understand which agent instance should be trusted for which task, what does it cost, what kind of failure patterns it's going to surface, and based on that, we build a trust profile, and using this trust profile, we can route the relevant task to the relevant agent. And the metric that is relevant for us is verified outcomes per dollar.
Hello, everyone. Thanks for staying here for our fellow panel. And I'm Zheng Hao. I'm from OKX. OKX is familiar with the exchange and the Web3 business. And this year, the AI is our annual strategy, and we invested so many products and resources. And I'm very happy to be here to discuss the agentic stuffs with you guys.
And I'm Ivan. I'm part of a team called Aragon. We are like an on-chain policy and permissions management platform. The topic used to be called governance between 2017 and 2024, and since then we've tried to like abstract that a bit and focus more on like what does that mean practically. I think the agent stuff is specifically relevant because we know that agents would circumvent prompts and like cheat around that. So I think potentially encoding controls and guardrails is a very like useful use case for blockchains and at the intersection with agents. So we know like limits and gates are sort of like table stakes, but what is like a missing primitive in providing controls and guardrails around agents? If you have to give like a single answer to kick things off, like what's the missing primitive?
Personally, I think it's we haven't really reasoned about what does it mean to have agent identity, and actually who's responsible, and particularly in like liability perspectives. I know that was a topic earlier, but and I think we have to look at analogies also in that space. Like think about in like e-commerce transactions, right? Like, is an individual at Amazon responsible if that transaction goes wrong, right? Not really, right? The corporation is responsible, right? And so I think that's an interesting thing related to agents, that we need to look at those analogies. And I think, identity is at the sort of the bottom of that, right? Like in terms of how you have to think about that.
The way we've been thinking about this, and to give folks a 10-second background on what we've been building at Near AI, is we've been building towards a vision of user-owned AI. So what does user-owned AI mean? To us, it means private AI, so confidential inference happening within places like trusted execution environments. It means secure AI, so we've been building our own secure agent harnesses. So agent harnesses similar to what an OpenClaw is, but a lot more secure. The one that we built is called IronClaw. And third is agent capable of doing transactions. So you guys may or may not have heard of Near builds one of the largest cross-chain trading protocols called Near Intents. It's able to do transactions outside of crypto as well as inside crypto. So I think about the question about security being an interesting one, because I actually don't think there's like one answer. I don't think there's a silver bullet. There's like many lead bullets where you can sort of target this at different points in the stack. I do think if you optimize for a model that becomes better in say 3 or 6 or 9 months, I think some of these can be controlled at the model LLM layer. One of the things we ended up doing is we thought deeply about how you architect agent harnesses. And you can actually control it very well at the agent harness level. Like we essentially built our harnesses to have 4 layers. There's an interface layer, there's a loop logic layer, there's a kernel layer, and there's a substrate layer. So you can actually control things very, very well at the kernel layer. And I do think anything that builds as an application at the application level on top of agent harnesses or on top of LMs can also control at the pure application layer too.
I think one thing that's missing in the agentic workflow is that we are not capturing the action exhaust, because with action exhaust, we will be able to see which specific agent instance is relevant for which task. Okay, at what cost, what are the failure patterns, and who authorized this specific action by the agent. So once you start doing this, you will start building a persistent trust profile for that agent instance. So this is very important because once you have this building block, you can start trust-based orchestration or evidence-based orchestration. Now, if you have evidence, you can easily, of course, do an audit of the whole workflow of the agent. So without this, it will be very hard to trust the agent's activities.
Yep, and from our side, we really value the security and the guidance rail for our users, especially for the agent users, because in our products, most of the users are still do trading, so touch the real money. So from our perspective, the first is we need to ensure the agent can really securely sign your transactions, securely hold your cryptos. So we leverage several like hardware devices like TE to make sure the fund is secure. And the second is we need to like have very fine-tuned skills to make sure your intent is correctly translated to the agent.
Yeah, I think I want to add something because I think, and I also have a question. So one, I think there will be no agents that are using one model, right? And that's what we're seeing with harnesses and a lot of workflows where you optimize model based on task, right? And you can learn that. And so I think the world of harnesses is where you hit all of these points, and you also can see it at the application layer as well, because that's where you get to interrogate what the user wants and what their intent is. But I also think the challenge sort of about user identity and user intent extends way beyond just the agent that you send out, right? Because the agents can spawn other agents, right? And pay for actions from other agents through things like X402. And so you have this tertiary problem, right, that also has all kinds of, I guess, exhaust, you mean telemetry, essentially, associated with it. And I also think that on the telemetry side, telemetry obviously has an implication of data, and so you also have to think about what data is private, what's not private, right, in that telemetry, and how you're using it is what is important as well.
I think like between your answers, there was like an interesting sort of like tension between like private inference, like the privacy preserving side of agents versus how do you trace liability in case something goes wrong? Like do you guys have an idea of how those two square out?
Yeah, so two things. One, just to get beyond the centralized party issue here, Microsoft just shipped 7 new AI models, which are all tuned as models that can work on edge devices. So if you think about decentralized compute, decentralized whatever that we're dealing with, these models are actually optimized for that. And so they're smaller models that have the same capability as like GPT 5.5 and Opus 4.6. That means you can get that type of capability on decent laptops and any of these decentralized compute infrastructure, which fits really well, obviously, with the point you're making about privacy, right? Because the only way to get privacy is not to send your stuff off your hardware, right? And so I think this is where a lot of the market's going, and whether it's on a phone or on a laptop or a gaming device or decentralized compute that you rent, right? It's going to stay as close to that hardware as possible because otherwise you're leaking a lot of data.
I don't think that actually using traces or exhausts, as Sumit has sort of mentioned, or using confidential call inference within TEs on the edge are actually incompatible. I actually think they are orthogonal. Right. So for example, one of the things we've been thinking a lot as well is that if you have traces of like logic or of actions that have happened with an agent, let's say happening within trust execution environment, you can actually enable the user to give permissioning of like either usage of those traces for debugging or permissioning or to understand what happened in a chain of logic or for training or for inference or whatever the case may be, right? But the key thing is that if it happens, let's say in a trusted execution environment where permissioning is gated based on the user providing permission or on an edge device, they have the right to decide how that data is used, right? So I think like both are doable at the same time. It's not like one precludes the other.
I feel like that implies like a very high level of user sophistication in my head, because like someone, like the user being able to digest output and be like, ooh, I should change permissions in this and that way. Like, I don't see many users like having the capability to do that natively. So like, how do you enable that?
I actually think this is the biggest problem that exists in crypto and in general in agentic finance, which is actually fundamentally a product and design problem, right? When a user uses BTC or ETH or Zcash, they don't have to understand how distributed systems work or decentralized databases work, right? They just go to a MetaMask, put in a password, and click buy or sell. You can abstract all of that complexity in agentic finance as well. I think the crypto as an industry, we've struggled to make that work in a simple way in the past, although some wallets are getting there, like Phantom is like well designed, right? And I also think on the agent harness space, we're also struggling there with some of the same issues. Like how many of your non-technical friends use OpenClaw on a regular basis, right? Probably no one. So I actually think it's a very solvable problem with better product and design.
Samit, sorry, you wanted to jump in?
No, I was going to say, use the opportunity to talk about something I talked about earlier as well. And I know you're doing work with OpenClaw. OpenClaw is such a great example, right? Because like it's a massive security risk in its native form, more so than any other open source code you probably used, right? Because of what it encourages people to do. And so another thing Microsoft shipped this week as well is a Microsoft safe version of OpenClaw, which is called Scout. It's actually the brand name they come up with. But we're also, any advances that we've done in the security that allows that to safely use the Microsoft Graph, which means you can log into all of the things that are privileged to an enterprise user, will also be contributed back to the master, to the OpenClaw open source software. So we've committed to that. We've just released the alpha. So in the context of a Microsoft customer where you do have a very rich graph of things you can do, certainly for any enterprise, you would know that. OpenClaw can now be safely used in that environment, and it takes advantage of the graph. So it's a really interesting, sort of lever that does solve some of those issues, but obviously in the context of an enterprise workload.
Samit, like what you described, it depends very heavily on like good outcomes as a sort of like benchmark against which you measure and learn like how to improve. How good is a very subjective word. Like how do you define good outcomes in the context specifically like agent spend?
Yeah, so it is quite contextual, right, and relative. That's why benchmarks kind of doesn't work for agents, right? Like, okay, you can see the benchmark of Opus, and then it doesn't translate into actual performance, right? Like, because your agent harness might be doing things in a different way. But then again, what's the unit of trust here? It's the agent instance. So different agent instances of Cloud Code itself, will have different career trajectory and will behave differently. So we set up like verifier agents, a set of them, and then based on the task and of course the intent and the goal, we try to come up with scores for that specific task. Okay, so right now we look at 5 different dimensions. We call them proof of agency. So we look at initiative shown by each agent instance, collaboration effort, efficiency, reasoning depth, and what kind of reasoning they will be doing based on the difficulty of the task. Now, based on that, like we get the verified rational, and then of course, then we still need the human judgment in, right? Like how suitable the outcome was based on what you wanted to get out of that agent, right? So that kind of like feedback loop helps in terms of like deciding how should the agent go forward. And then again, the autonomy question depends on these things, right? Like, okay, you have an verified outcome, and then based on the evidence that comes with the verified outcome, we can make a decision whether the autonomy should go up or should we dial it down.
Zhenghao, you were like nodding while he was describing the KPIs. You want to weigh in?
Yeah, actually, I quite agree that the good outcome is quite subjective, and in my mind, actually, there's two perspectives. The first is like for agents, the good outcome is not it's not evaluated by the actually executions. Actually, it's evaluated by how does it compare with your intent, right? So maybe it gets 100% successful rate, but it didn't give you the always the best price or best outcome from the trade, right? And the second is it should be like reliable. Like the agent, sometimes it can fool you. Like if you give them like a fixed prompt, sometimes it gets some illusion. It just give you some surprise, right? So yeah, I think the two dimensions or two standards is the good outcome from my end.
Yeah, and I think I would just want to add to this, like contextually, like you guys are all living on the frontier, obviously, right? Like, and I think what we have to explain to people related to this problem is, if you think about what a user's doing when they chat with an agent or their chatbot or with Claude, you're giving non-deterministic input and then throwing it into some tool, right, a model, which comes back with non-deterministic output. And if you think about policies, controls, and governance, this is not something we've ever dealt with, right, realistically in software before. And so it is a completely different game and environment. And now you add agents that can spawn agents on top of that, and you're multiplying this problem, right? And so it's a really interesting challenge, and especially when you start to go build applications with it, and you realize these problems, right, and you're trying to create evals, right, evaluations to determine whether the output's what you expected specifically for your application, it wakes you up immediately that this is not an easy problem to solve unless you have very specific guardrails and resources that you're pulling on. So contextually, I think it's really important to understand that, because it is very non-deterministic, right? Spawning agents to go do stuff and pay money to a specific service that the user never approved but was given a spend approval, right, is non-deterministic, right? And so how do we think about that broadly from a governance and a policies and a controls perspective is an interesting problem.
Yeah, just one thing I want to add. So that's why a role shouldn't be assigned to agents. Like, okay, some agent XYZ go like take $1,000 and go spin up more agents and get this thing done. Agents should earn that trust and their role.
Yeah, I mean, reputation is clearly important, right? And I mean, it's something that I think people in the decentralized world recognize, right? That people outside the decentralized world recognize less, right?
I agree with a lot of the things my fellow panelists are saying. Disagree with some of it. And then I also want to throw out maybe a few spicy questions, if that's okay.
Yeah, go ahead. Especially if you disagree on something, just dig in.
Yeah. One of the things, Sumit, you said is that you don't think benchmarks will end up being as useful. Totally agree. Obviously, we have, in different sort of situations, stochastic inputs, stochastic outputs, right? But if you don't end up using benchmarks to actually try to assess the outcome of a model or a harness or an application, how else would you do it? And I also agree that, by the way, that I think the traces will be a really, really important part of this, right? Because I do think you can use the traces to improve the model, to improve the harness, to improve the benchmarks over time, right? As well as to give things like, more enhanced permissioning. But I'm kind of curious to get your take on the benchmark question.
Yeah, so benchmark still, it's like a generalistic, it's done over generalistic test, right? So that benchmark may not hold on my specific code base on my specific context, right? So I want my agent to be evaluated on my code base, on my project, right? So for that, we need this action exhaust of what my agent is doing with the context that I'm providing, with the code base that I'm exposing it to, the APIs that it's allowed to, make calls to or other tools. So with that, I think, like you get the loop and then this trust profile gets built for the agent on my code base.
So you're saying using the traces, we may be using different terminology. You're saying using the traces as a key input into evaluating the outputs of the actual agent itself?
Yeah, so trace is one part of it, right? So we start from the prompt itself. So it might be my wrongdoing that I'm giving a vague prompt to my agent, right? So it starts with pre-execution stage itself. Then you have the execution, that's where the traces comes in, or the action exhaust. And then in the post-execution is when you want like the outcome to be verified. Again, it's quite relative, but then how satisfied the user is going to be, that input also matters.
Speaking of vague prompts, something that like I deal with a lot in my daily life is scope creep when the client has a vague prompt. My understanding is it's called drift in the AI space, like behavioral drift, right? So if we're indexing or relying on identity and reputation, but like the behavior of an agent drifts over time, like how do you account for that? How do you account for drift if your like reputation and identity is purely backwards looking, and like are you gonna like overweigh more recent actions? Like how do you guys think about that?
Yeah, I mean, generally, I think the way you solve that in, like, the thing that you should assume, by the way, if you're doing any kind of AI workload or agentic workload, you have to be able to prove to other people that it's doing what it's supposed to do, right? And so that means you have to have repeatability in test cases. And so that's kind of how you monitor for drift without the exhaust examples, but like that's what you have to actually do in the workloads. And if you can't do that, you don't have the test cases, then nobody's gonna believe you that it's actually gonna work, right? And so that's your sort of starting point, right? What are the evaluations or test cases that you can spin up a container and spin up your workload, spin up another one, have them execute, and actually produce the exact same output, right? That is the test. And if you can't do that, then you're pretty much toast, right? And so I'll let you guys comment on that.
I think about it a couple different ways. So the times when I've noticed drift happening the worst is when essentially context windows get large, right? There are a couple different ways to solve it. One is essentially to use really great memory features, which is controllable at the hardness level, right? So maybe that is one way to sort of solve this issue. I think maybe other things you could do to solve this is like very thoughtful sort of controls at the application level as well. Those would probably be the ways I would think about like addressing this.
Yeah, and just to mirror that, when I said workloads, I meant harness and application controls, not just an AI model, right? You can't actually just do an AI model and expect it to perform the way you want, not with an LLM, right? Because it's predictive, so.
Yeah, I think that's why building trust profile over time for a specific agent instance becomes valuable in terms of like identifying why a drift is occurring, based on like what specific context and tools and so on and so forth, or what kind of failure patterns this specific agent is showing or its history, right? So this verified history or this evidence, like helps us then take operational decisions, right? Like, okay, maybe the agent is drifting because we gave a lot of context, right? Like maybe it's failing on some points, on some workloads, or maybe like it's retrying on some tasks again. So all of this pollutes the context, also the memory of the agent as well, and then drift is when you will start experiencing. So once we know the root causes, right, like we can try to avoid them, like work around them, and then decide, right, maybe this agent is not the right one for whatever task you gave it to it.
But I mean, like assuming we're in crypto, we have this like testing in production kind of situation for a long while. So it's still like solutions you guys are talking about still sound like somewhat like reflective of like, oh, like the agent is not performing as intended. Of course, I'm gonna like phase it out. But like what happens if you realize it's not performing as intended with like actual capital on the line, like with in a live situation, in a live environment?
So I know some YC companies in the legal sector aim to end up trying to solve a version of this problem. And I think the way they try to solve this problem is with really good tests, right? Just exhaustive tests, right? That ended up being, I think, their approach, just given how important it is in legal to be able to actually give correct legal opinions, right? I also think you just have to, by nature of the product itself, it's stochastic, right? You're going to get certain kinds of randomness in the outputs of the models, right? I think a combination of using exhaustive tests to try to control the outputs as much as you can, and for any instance where you really need to control the sort of like starting place of the model itself, really utilizing and updating really good memory files and keeping the context window length is probably your best bet at like controlling the outputs.
Or you just send multiple agents to do the same thing and then you like consensus, Byzantium fault tolerance kind of situation. I'm just throwing crypto at it.
Yeah, I mean, like in some sense, like crypto, which is extremely deterministic, right, is the complete opposite of AI workloads, right, that we're relying on LMs that are predictive, right? And so think about like the experience of a user that's not just sitting at a chat window, right? The experience of an AI solution behind a user experience that is supposed to do something very specific. The AI model that you choose for that task has to actually be specific to that task, right? If it's something where you expect a quick response, then you need a model that returns results in 3 seconds and doesn't give you paragraphs, right? And so the entire tech stack that you're building, you have to think through what tools am I using, how, and this is where the harness comes in, right, and the application experience is, how is my application experience going to perform based on the type of model that I choose? All of the massive amount of testing that we see when you do an upgrade, say on an Ethereum network, right, it's like a year of work, right, to get through that. This same type of diligence has to go into, obviously, anywhere where there's money being secured, but in this world where we don't exactly have the history associated with building these applications, right, you have to spend a lot more time doing due diligence to get to a comfort level yourself that you're sure like the thing's not going to screw up and spend your money in the wrong way, right, as a corporation, right, or as a business or as an end user, right?
You guys have some closing thoughts on this? Or anything else you want to like share in the remaining few minutes?
Yeah, I think like, you know, like having a layer on top of this agentic harness or like the agentic layer itself, like where we have, where we can build a trust memory basically, which allows us to see what my agent is doing, at what cost, you know, with what failure patterns and with what authorization. So this kind of like, this kind of exhaust basically compounds over time as I keep running my agent through this pipeline. And this will help me keep improving my agent and understanding how to basically keep operating with it.
Think you want to close?
Yeah, and from our side, because we are more good at like building like user-end product, so we are trying to find out the more user-side solution for that. And actually, we use the for example, the EIP 8004, like the open Ethereum identity standard, to let to let agents to evaluate each other to see if your opposite agent deliver a good result to you, and we do see some missing part here because we try to build some like A2A product, A2A commerce product, and we didn't see like any like industrial like consensus standard for the agent identity. And since this is the part like all the partners can work together.
Okay.
Yeah, I just want to comment because it might sound like I'm not bullish on this, right? Like, this is one of the most exciting times you could ever be starting your career, and it's one of the most exciting times that you can build things that you don't have the constraints on us that we could build before. So what that means is domain experts have incredible agency to go out and build new things. And to me, that is the most exciting market that we could ever be in. And certainly, I have students who are just coming out of master's programs, some of which are here in the back. And it is an absolutely exciting time to be doing this discovery at the beginning of this market. So as exciting as all of us in the crypto markets have been about crypto, now we get to be that way about agents and crypto and AI, right? So it's a very exciting market.
Nice. On that bullish note, we're going to go do something that hopefully will not be outsourced to agents soon. So we have some drinks. Thanks, everyone.